Heading into lesson 5-2, which should be on page 5 in your notes. I would definitely encourage you following along on those. All right, and our goals today is to use criteria, or congruence criterion of corresponding congruent parts of triangles to solve problems, and use the third angles theorem and the properties of triangle congruence to solve problems. All right, so the principle of superposition states that two figures are congruent if and only if there is a rigid motion or series of rigid motions that maps one figure exactly onto the other. Okay, so recall that congruent figures have exactly the same shape and size. So really what they're saying is that if you can take two shapes and somehow move them exactly right on top of each other so that they perfectly line up, then they are congruent. Okay. Then the next one says, in two congruent polygons, all the parts of one polygon are congruent to the corresponding parts or matching parts, the same location of the other polygon. These corresponding parts including all of the corresponding angles and the corresponding sides. So what you need to know is that congruent polygons have congruent angles and congruent sides. Okay? So for instance, let's grab a triangle here. I'm going to make any kind of triangle. Copy it. Oh. And we're going to paste it. There we go. All right, and now grab another color. In it, it should have, all the angles should be the same. One, that one should be the same as that one. This should have a matching angle here, and then matching angle here to here. Okay? Congruent angles, all matching up. And then each side should have a corresponding side that it matches up with. Just like that. Okay? Corresponding sides, corresponding angles. If any of those don't match up, you do not have a congruent polygon. Okay? All right. Two triangles are congruent if and only if all of their corresponding parts are congruent. And then this guy right here, we want you to tuck in your back pocket because you are going to use in proofs. Okay? For triangles, we say that corresponding parts of congruent triangles are congruent. So this is the whole long thing right here. The corresponding parts of congruent triangles are congruent. You see all those corresponding parts of congruent triangles are congruent. And we shorten it up to CPCTC. What that means is if I tell you that something like triangle ABC is congruent to triangle DEF, then I immediately am going to know that angle A is congruent to angle D. And I'll show you why in a minute. But A and D are both parts of those triangles, and they will be congruent to each other because they are part of those congruent triangles. Okay. So let's take a look here. This is an example on your notes, and it's already been written out for you, but it says show that they are congruent by identifying all those congruent corresponding parts and write a congruence statement. This word right here can be confusing. This is a statement that says something is congruent to something else. So that would be like I said before, triangle ABC is congruent to triangle DEF. It's a statement that equates two things, that puts them together by congruence. So here are those statements. They went through and said A is congruent to W, right there. Angle A is equal to W. B congruent to X. C to Y. D to Z. So they went all the way around and did all of the angles. Then they went and did all the sides. Notice the notation. That segment notation because it's congruent, okay? When we use the congruent symbol, you have to have the segment line on top. In ALEKS, they will be particular about that, okay? And then they came down and wrote out the statement. Polygon ABCD congruent to polygon WXYZ. And you can also write it out as ABCD congruent to WXYZ. Now, this is a specific order. You have to go in the order of congruence. So let me see if I can, I'm gonna go a little bit thicker here. If I'm going from, let's see, going across here, A to B to C to D. So I'm going from A to B, then B to C, and then C to D in that. I'm going from my single angle to my double angle here. That means I need to go from my single to my double here. So I need to go from W to X, see? W to X. And then I need to go from my double to my triple. So I need to go from X to Y. And then from my triple angle to my quadruple angle. Okay. I have to go in the same order in my congruent statement to match up my letters. Now, why that is really important and why it's super cool is because it gives me a roadmap. That means that angle A and angle W are the same. I now know that angle A is congruent to angle W just by looking at my congruent statement. I can also know that angle B is congruent to angle X because they are in the second position. I can know that angle C is congruent to angle Y because they are in the third position, and so on and so forth. You can also, okay, I don't know if this is going to blow your minds, you can do your segments too. Look at this one, BC, look at, here's BC. They're in the second and third spot. Let's do the second and third over there. That's XY. What? Super cool. Let's do another one. AB. AB are in the first two spots. That would be W and X over here. Yep, it works. Okay? So your congruent statement, this is a roadmap for all of this and all of that. Okay? It has to be in the correct order. All right. I hope that makes sense. And I hope it's helpful. All right, now you guys are going to go ahead and do this one. Go on to page 6 in your notes and write out all of the congruent statements for the angles and the sides for polygon PQRS and its other polygon. Pause me and come back. Right. Did you get these? P goes to G, Q goes to F, R to E, S to D. PQ goes to GF, QR to FE, RS to ED, SP to DG, SP to DG, sorry. And the big one, PQRS goes to GFED. Hope you got those. All right, let's go on to the next one. Now, in this one, the diagram, triangle RSV is congruent to TVS. They give this. This is a given, okay? Since they gave that to us, that means we can assume all of the congruent parts of a congruent triangle are congruent. Remember that CPCTC? Congruent parts of a congruent triangle are congruent. Okay? What that means then is we know all those things that are congruent. We know that angle R is congruent to angle T. Angle S is congruent to angle V. And then angle V is congruent to angle S. Now that's confusing. That confusing because S is here and S is there and V is here and V is here. That's because we've got two triangles, one's here and one's here. We're gonna kind of have to watch because, let's see if I can erase the colors. Oh, there we go. Let's put that angle back in there. Okay. Let's see, RSV is on this side, so this S and this V are on this side, and the blues are on this side. There we go. So we have to kind of watch ourselves just a little bit there. And when that happens, if you've got the same letters, what you can do is you can add more letters on either side. You can say, I need a few more letters in here. I'm gonna pull this off. Let's see, get rid of the green. And on either side of this S over here is RSV, okay? And on either side of this V, now that's a little bit more tricky. Here's the V. Well, S is on this side. What would be here? Well, you'd have to wrap around to the front and it would be R. So that's your actual angle. So you'd get RSV and SVR. Okay, so anyhow, so you can find all those pieces, the angles. And then you can also know that your sides are going to be equal. So your RS is congruent to TV. Your SV is congruent to VS. And your VR is congruent to ST. Okay, so we got all those pieces. Congruent parts of congruent triangles are congruent. Now it tells us to find the value of X. We have X right here. X is in angle T. X is right here in angle T. Well, angle T is equal to angle R. Do we know how big angle R is? Not yet, but we can solve for it. So down here, this is what it walks us through. If T is equal to R, so then the measure of T is equal to measure of R. And measure of R is going to be equal to 180 minus 90 minus 78. That's going to be 12 degrees. So the value of X is 12. Now, part B, they tell us that they want us to find the value of Y. So that's over here. That's this length, RS. RS is equal to TV. Okay. Well, if those are congruent, we can set them equal by the definition of congruence. And then we can substitute in their values. So there's your first fill in the blank. And then we can solve, which gets us down to 12.5. So the value of Y is 12.5. Right. Hope that kind of makes sense. All right. Okay, so what if they had not given you that the triangles were congruent? Would you be able to solve this problem? If they had not told us that this triangle was congruent to this triangle, would it be possible to solve for those? I hope you're thinking no. Because while this looks like a 90 degrees, it appears to be congruent or appears to be 90. That's an assumption. So we cannot assume. And so without them telling us that this is congruent, we can't assume anything about those triangles. So no. All right, I'm going to have you pause me while you solve example 2, this check. Solve for x and y. All right, did you get that x was 10 and y was 53.13? I hope so.